did in last discussion, we ended up saying that how to price the returnable debt. Price returnable derivatives. We have again two approaches. One was replicating portfolio. So when I'm saying that my derivative D is returnable, means that there exists an investment in a strategy X and Y, such that when you compute its value at time 1, it's going to replicate you. So it's going to attain to. You can construct this using the value of the investment strategy X and Y. And once you have such an XY, then law of one price tells you that the price of this derivative should be what the value of this portfolio that time doing it through portfolio strategy. And the second thing, or the second way was that if your derivative is attainable, then in a viable model, obviously. So viability is the first step. I mean, if your model is not viable, just go and fix it first. Okay. And the second method was that, okay, if you want to compute the price of a derivative, then just probability of what you call one price is that then construct equivalent martingale measure, okay, and then compute the expectation of that equivalent of discounted value of the derivative with respect to that equivalent martingale measure, and that is going to give you the fair price of the derivative. Okay. So if my derivatives are attainable, then I'm going to have something which is called the unique fair price. Not only have a fair price, but it is unique. Okay. And then we also did what we call second fundamental theorem of asset pricing, which says that if n is bigger than 2, in other words, if your model involves more than 2 scenarios, then your model is not complete. In other words, there are going to be, derivatives which you can't price. What to do, or what you can't uniquely price at. If you can't find a unique, price of a derivative, or go with multiple scenarios and single stock, then what should we do? So our next task is to basically come up with that how to pricing the non-attainable derivative. Okay. Non-attainable derivatives. For which you don't have this one. We by non-attainability that you can't have X and Y, but you can replicate. And you can't find fair price. Unique fair price. I mean, if you can't find unique fair price, then the naturally question arises that can we find kind of a range of fair price actually, to which we can say, okay, if your price is between this interval, you are okay. And if your price goes beyond this interval, you're going to have an arbitrage opportunity. So it's like this one. So it's like I have this product. I don't know what is the unique price of this, for example. Then what happens usually in market? You must have seen it. that the seller is going to basically sell it at a particular price. And he's going to ask for some particular price. He's going to ask for some particular price. Give me 10 rupees for it. And the other party, the buyer, is going to say 10 is too much. Right? 10 is too much. And then you're going to have roughly bargaining. But the seller must have a lower bound as well. He's going to say, no matter what happens, I'm not going to sell it, below 6 at. So people have to agree, buyer and seller has to agree between 6 to 10. And if the seller sell this product over time, it's not a fair price over time. Fair price for the buyer. Okay. The seller is going to make unnecessary money. Unethical money. But if he sells, for example, below 6 actually, then the buyer is going to be happy, but the seller is not going to have. It's not a good price for it. So it's like this lower price is what you call the bid price. Okay. So it's like, have you seen bidding process somewhere? At least you must have seen movies. That it begins with something. Okay, so that's the least price of it actually. But there is no top price of it. People can compete with each other. So we are saying that there must be some. It's like the price of the object should not go beyond this. It shouldn't be below this. So this top price is called ask price. The seller that is going to ask it. And this, lower price or at a bid price. So because if you don't have uniqueness of your prices, then you're going to basically think about finding that what should be bid and ask price for your derivative. And in order to define ask and bid price rigorously, I need to define two terminologies. Definition. So we're going to say that portfolio phi super replicates a derivative of D if at time 1 the value of the portfolio exceeds 1. That's super replicate. And the value of portfolio phi subreplicates the payoff of the derivative D if phi is I'm going to define ask and bid prices in terms of these two things. So one of the things which is immediate consequence of this definition of first remark would be that if I have a portfolio which super replicates and sub replicates, so it replicates the portfolio. Super replicated and sub replicated. That it is replicated. Okay. But if you are in the case of non-attainable derivative, you're not going to have this. You have either of following. Now, why super replicating portfolio is a good portfolio? It is doing something interesting. Why a person should be interested in, for example, super replicating? Imagine you are the seller of the derivative. Okay. By selling the derivative, for example, at time 0 and creating this portfolio is going to do something else.
Difference.
It's going to do something. So when I first like just think about it. So I am taking a short position in a derivative, I'm selling a derivative. Okay. So I'm exposed to risk. So if I'm exposed to risk, then I must do something to hedge it. Okay, I must do something to hedge it. So, and I know that this price is not attainable at, so I can't find such kind of a strategy. Okay. Then what option I have? Then one option I have is that create this super replicating portfolio. So when you're gonna have, some premium by using derivative invested into the creation of the super replicating. And once you create it at time 0, you know for sure that at time 1 I can meet with this obligation if something happens. Because the value of the portfolio is going to be bigger than the payoff of the derivative. So if the other party, the person with the long position in the derivative, is claiming the right of, for example, in case of option, okay, so it's claiming his option, then I know that value of my portfolio is bigger than this claim action. So I can easily meet with the obligation. So at least I can meet with the obligation. Is it making sense?
So B1 phi, isn't that a random variable? So how would we be able to create?
I know that the portfolio XY that I created at time 0 is going to give me this information, this value of the portfolio, and which I know that is going to be bigger than
T.
the value of the D.
Nice.
It is same as that, it's a portfolio XY, which is going to give value equal to T.
Right.
I mean, depending on the given model. So we are saying precisely the same. So it's like you observe something like that. You say that you have you sold actually a derivative which you can't price uniquely. Okay, and then it's better to create a portfolio. Okay. Now, if I want to make this, so I created portfolio at time 0, okay, by selling the derivative. But I know that at time 1, the value of portfolio is going to, since it is bigger than D, so I mean if I have to pay D, I have to pay D, I can do it from here. Okay. If I'm lucky enough, okay, in one scenario, it's strictly bigger than maybe I can have some money in the pocket, right? Okay. We can even show that if for at least 1 omega, V1 phi is strictly bigger than D, V1 phi of omega is bigger than D of omega, okay, then I can create an extended arbitrage. Okay. So if I can create extended arbitrage opportunity, you shouldn't be able to do it. You need to stop it. Okay. Now just think about it. Think about this difference. P1 phi, P1 phi is bigger than or equal. So if this difference is too much, if this difference is too much, what's going to happen?
Discrete time.
It's going to be a risk-free profit. It's going to be kind of a way to create it. So we shouldn't allow it. So what we should do? Okay, we have to make sure that the difference of these two things should not be too much actually. Okay? And how you can minimize this difference? Okay? You can minimize this difference by saying that imagine, I'm going to show this physically so you can go more sense. Imagine I have set of portfolios 5, okay? And it's set of, not set of portfolio, but set of values of the portfolio 5, such that phi replicates, okay, they can be lots of portfolios which can not replicate, but super replicate. Super replicate. So there can be lots of portfolios which can super replicate.
Choose the minimum.
Choose the minimum one. So therefore, what you need to do is compute the infimum of this. Okay. And let's give it a name. It's what's called the ask price. Must be ask price. Ask price are the seller's price for the DS. Now, why this is something good actually? This is something good that if your price of the derivative goes beyond this number, the premium, the B1 phi, but the B not phi, because for the price you should have B not phi, not the B1 phi. Okay, so I have collection of portfolios which super replicates D. So it's like I know that for phi, you know that thing is true, that inequality is true. And which is the portfolio which is going to give you the minimum of V naught phi? And that minimum is going to be what you should be, what you call the ask price. Like ask price for D, sometimes we also call it seller's price. It's like an ideal price for the seller for this product. Okay. So if the price of this object goes beyond this ask price, the seller is going to make something unnecessary profit, or maybe through risk plus profit. Okay. And what do you think? What should be other way around? So it should be
Lower bound.
what should be that? Bid price. In other words, what is the ideal price that buyer should ask for?
Greatest. Lower bound.
Okay. Supremum. This time. You see how these abstract notations are being incorporated. So it's like a supremum of the value of the portfolio phi, where the phi subreplicates. What should be the interpretation of this inequality? Okay, we had interpretation of this inequality. We say that if a seller is selling the derivative D, okay, then he must ask for the ask price actually. Why? Because if he sells this derivative at ask price, then he must be able to create a portfolio which super-replicates the derivative D in such a way that the seller is not making unnecessary risk as well. What should be the interpretation for this idea?
Buyer
It's going to be from buyer's perspective. Okay. Good point to reflect on. Okay. So buyer B is what that we call the bid price. Buyer's price. Buyer's price. Okay. The next thing that I would like to prove is this. Yes, I'll not prove this theorem abstractly. I'll do it through an example. Okay. But the argument that is being used in the example is the argument that is being used in proof of the theorem. Okay. Theorem is this. In other words, let's formalize what we have discussed so far. So imagine I have a non-attainable derivative. D is non-attainable derivative. Okay. Incomplete single stock model, obviously. Okay. Then there exist super-replicating and sub and sub-replicating portfolios for A and for B respectively. Okay. And such that what should happen? Such that if you compute the value of this super-replicating portfolio phi A, what you should have? You should have the price of that. And you know phi B. Okay. Not only this, that you have ask and bid prices, any price between ask and bid price is a fair price. Okay. Any price between them. And obviously, this must be smaller than B must be smaller. Okay. The theorem hence by B is smaller than by A and pi is a fair price for D if and only if pi is sitting between pi A and
By B.
pi B. So any price between them is going to be a fair price. Okay.
So why not equal also? Why is strictly greater?
You can have equality from one side, okay, but you can't have equality. I mean, I can't write this. Okay, that's not equal. That's it's going to be. Then all three can be equal, which is going to violate this. So it's safe to say. So obviously these two prices are included. They are there. Okay. So along with these two, you want to also have any price between them as the fair price. Okay. This summarizes, what you call the approach of pricing the non-attainable derivative. Okay. If your derivative is non-attainable, then try to find sub-replicating portfolios and super-replicating portfolios. Once you have sub-replicating portfolio and super-replicating portfolio, those are your ask and bid prices, from sellers and buyers perspective, and any price in between. Give example 6 to 10 is a fair price. Okay, and any price which goes beyond these two prices is going to be the approach. You create an arbitrage. Okay. So what I would like to do, I would like to almost give proof of it. I can just show it pictorially as well. I mean, future. Even a rough sketch, a human sketch. For yourself. But I'll give you the essence of it. Here's a sketch of it. And this theorem is going to put, what you say, last brick in almost everything single thought, several scenario model. Because we know what is meaning of viability of such model. you know that if n is bigger than 2, you can't have completeness of now.